Okay, everyone, we're just going to do a quick review of some chemistry concepts that you probably learned in junior high. We might be adding a little bit to what you learned in the past. First of all, we'll start with matter. Matter is anything that occupies space and has mass, and mass is how much matter an object has. Weight is sometimes compared to mass. The astronaut's weight changes depending on whether he or she is in space or on Earth, but their mass never changes. So weight is the force of gravity pulling on an object. If you remember from junior high, we also had the periodic table of elements. Remember that an element is anything that cannot be broken down into simpler kinds of matter. There are more than 100 on our periodic table, but fewer than 30 of them are actually important to life. The rest of them are found in the Earth itself, but they're not important to life. We'll talk about the ones that are most important to life in just a moment. Okay, all matter is made from or made of atoms. It consists of atoms and molecules. I think most of you remember the parts of an atom. First of all, an atom is the smallest unit of an element having all the characteristics of that element. Within the nucleus, I forgot this was coming first. The electrons are what orbit around the nucleus. The electrons are teeny, 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 tiny, and sometimes we say they have no mass. They really do have a mass, but we ignore it. They are negatively charged, and they are completely what's involved in bonding. So whether it's an ionic bond or a covalent bond, electrons are involved. The protons are found in the nucleus of an atom. We give them a mass number of 1. So they have a mass of 1, and they have a positive charge. Neutrons, as the name implies, are neutrally charged, and they also have a mass of 1. The protons and the neutrons put together are what really make the mass of the atom, since the electrons have such a negligible amount of mass. Molecules are basically a whole bunch of atoms put together. So the definition of a molecule, the smallest particle of a substance that retains the properties of the substance, but they're always composed of 2 or more atoms. That's what separates a molecule from an element. An element is a single atom. Sometimes they bond together, but a molecule is composed of 2 or more atoms. Continuing with things that came up probably in junior high science class, we'll talk about the atomic number. The atomic number is really the thing that identifies an element as an element, and it is the number of protons. For example, carbon always has 6 protons. The number of neutrons might have changed, and the number of electrons might have changed. By definition, carbon has 6 protons. If it had 7 protons, it would be a different element. The mass number, remember that electrons have almost no mass, but that protons and neutrons both have what we call an atomic mass unit of 1. So if for the total mass of an atom, you just simply add the protons and the neutrons. An ion is any atom that is either positively or negatively charged. And the reason it would be positively or negatively charged is that it lost or gained electrons. The number of protons always stays the same. So for example, oxygen always has the same number, or carbon or whatever, always has the same number of protons, but the number of electrons may be traded. They might lose electrons or gain electrons, and that can lead to a positively or negatively charged atom if the plus charges and the minus charges are unequal, and then it's called an ion. And then finally, an isotope. We talked about in our evolution unit about radioisotopes. An isotope is an atom of the same element, carbon for example, but that has different numbers of neutrons, so the mass is different. Carbon-12 is the most common form of carbon, and it is not radioactive, and it's not what we talk about with radioisotope dating. Carbon-14 is much less common, and it is radioactive. The difference between carbon-12 and carbon-14 is that carbon-12 has 6 protons and 6 neutrons, whereas carbon-14, if it's carbon, it still has 6 protons, but this time it has 8 neutrons, and that's the primary difference between carbon-12 and carbon-14, and then that makes it radioactive. Okay, ionic bonds are bonds that occur when one atom donates electrons to another atom, and that causes them to become ions. Notice in the example below, the sodium ion has an extra electron, and it donates that free electron to chlorine that is missing an electron. It's supposed to have 8 electrons in its outermost shell. When it donates that electron, Now the number of electrons is one less and the number of protons is one more, so it has an overall, sodium has an overall positive charge. The chlorine has gained an extra electron, an extra negative charge, so it has an overall negative charge. So we call these ionic bonds because you're forming two ions. Because the atoms have a positive and negative charge, or the ions have a positive and negative charge, they are attracted to each other and they tend to sit near each other. Many of you might recognize this particular reaction as the reaction that forms salt, table salt. Okay, in contrast to ionic bonds where the electrons are actually taken or given away, in covalent bonds, the atoms share the electrons to form a neutral molecule. So carbon and hydrogen are good examples of atoms that tend to share molecule or share electrons. So the carbon is sharing an electron with hydrogen and it shares 4 times, so it needs 4 different hydrogens to make itself balanced. Okay, and this is the last thing that we're going to talk about on this unit is just the most common biological bonds in nature. They spell out a dumb word, HONC, H-O-N-C, hydrogen, oxygen, nitrogen, carbon. The reason that dumb word is actually kind of handy, 96% of all living matter is made of these 4 elements, and it also happens to be the order in which they bond. That didn't make sense. The number of bonds they make, there we go. Hydrogen is the first letter in the word HONC, and it makes 1 bond. So hydrogen is 1, and it makes 1 bond. Oxygen is the second letter in the word HONC, and it makes 2 bonds. Nitrogen makes 3 bonds, and carbon makes 4 bonds. If you know that, that can help you when you're working with the biological molecules to make sure that a molecule is balanced, that carbon, for example, has 4 bonds. If it only has 2 bonds, then you know the molecule is unstable. All right, that's it.